Okay, hey y'all. Today's about angles of elevation and depression. So you have two situations. An angle of elevation means you have somebody on the ground that's looking up. So you have the sight line, and the sight line meets a horizontal line, the ground or some sort of horizontal line. And the angle between the horizontal line and the line of sight is going to be your angle of elevation. And it's formed by, this says horizontal line and the line of sight looking up. So this is horizontal and the line of sight looking up. The angle of depression is when you have something up high, you have a horizontal line is up high, and then the angle is with the line of sight looking down. So in this picture, someone's in a hot air balloon and they're looking down at the target. So the distance, the angle measurement between the line of sight and that horizontal line is called your angle of depression, formed by the horizontal line and the line of sight looking down. And with all of these, we're going to be making right triangles. So, notice, just something for you to notice, that when you have a horizontal line and they're parallel, then your angle of depression and your angle of elevation are congruent. Because this is parallel lines cut by transversal. These are actually alternate interior angles. So they are congruent. Just a piece of the geometry that you need to know. Alright, so example 1. A tree is 10 meters high and it casts a shadow that's 17.3 meters. Find the angle of elevation. So here somebody's looking up and they want to know the angle of elevation, the end of the shadow to the tip of the tree. So over here, I have first find the right angle, and here's the right angle. Once you find the right angle, then you kind of have your bearings, and then you know that this is going to be the hypotenuse, and this is the angle from the perspective that we are looking at. Next, we want to use sine, cosine, or tangent. And from this angle, this is our opposite side, and this is our adjacent side. Now, because the values I gave you in this problem were opposite and adjacent, that tells us that we want to use tangent. So tangent of the x angle is equal to the opposite over the adjacent, which means tangent of x degrees is equal to 10 over 17.3. Now, because we are using tangent to find the angle, that means for this problem we would have to use the inverse tangent on both sides, so tangent inverse. And when you do that, you're going to get about 30 degrees. So that means this angle of elevation is looking up at a 30-degree angle. Example 2. A shark swims 22 feet below sea level. If the shark is 67.7 feet from the sailboat, what is the angle of depression? So I've shown you here the angle of depression that we're looking at, because here's your horizontal line, and the people in the boat, let's say there's somebody in the boat, they see a shark, they're looking down, and then they freak out because they see a shark. Now, or maybe they're like happy that they're going to see a shark, I don't know. Number 1, find the right angle. Here is our right angle over here, which means this is our hypotenuse. Hypotenuse. And we need to decide if we're going to use sine, cosine, or tangent. From this angle, this is our perspective. This is the opposite side and the hypotenuse. If you want to use the opposite and the hypotenuse, then we need to use sine of x is equal to 22 over 67.7. Because we need to find the angle, I forgot my calculator. Because we need to find the angle, I'm going to use the inverse sine, make sure it's in degrees, so the inverse sine function and I'm going to type in 22 divided by 67.7, and it is 18.96, so about 19 degrees angle of depression. So that means we're looking at about a 19-degree angle going down. Okay? So now, just another thing, in these problems, we're going to be setting up right triangles and using our trig functions. Remember, if you're looking for a side measurement, then you're going to set up your proportion, cross multiply, and divide. If you're looking for an angle measurement, then you're going to have to use the inverse trig function.